All right, here are the AP classroom questions for recap number 5. I apologize, there were 6 of them this time instead of 5, but I think you can handle it. It says, on a certain day, the total number of pieces of candy produced by a factory since it opened is modeled by C, a differentiable function of the number of hours since the factory opened. So the input is going to be time. Which of the following is the best interpretation of C prime of 3 equals 500? Well, C prime needs to be a rate at a specific instance. In this case, t equals 3. So this says something about producing during its third hour. That word during would imply over an interval. Not going to happen. Produces number of pieces of candy. Nope, we need a rate. The factory is producing candy at a rate. Ooh, that's potential. The rate, that has potential. And there was no E. Great. So we're down between these two. D says the rate at which the factory is producing candy is increasing at a rate. Well, this 500 is the rate. It's not talking about how that rate is changing. That would be the second derivative. So we don't want that one. It would be C. The factory is producing candy at a rate of 500 pieces per hour, 3 hours after it opens. Another way to think about it, remember, is your units. So our model C stands for candy, is dependent on time. So this is going to be the change in candy over the change in time, 500 pieces per hour. So candy is pieces and time is, let me write that again, time is hours. Oop, that's the L going by, if you can hear that train noise. Okay, question 2. The height above the ground of a passenger on a Ferris wheel T minutes after the ride begins is modeled by the differentiable function h, where h of t is measured in meters. So the height above the ground, okay, t minutes after the ride begins. So h of t is the input, time, and h is the output, which is height. So our h prime is going to represent the change in height over the change in time. We would be talking at a specific instance. So the Ferris wheel is turning at a rate of 15.70 meters per minute when the passenger is 7.5 meters above the ground. Well, 7.5 is an input, which is a time. So 7.5 does not represent meters, so that's out. The Ferris wheel is turning at that rate per minute, 7.5 minutes after the ride begins. Well, this function is not talking about the Ferris wheel turning, right? This is talking about the passenger's height, so that's out, which is also a reason maybe why A should have been out too, but other reasons to throw it out as well. The passenger's height above the ground is increasing. Okay. 7.5 is not a meter representation. Can't do it. Passenger's height above the ground increasing. Okay. 7.5 minutes. Yep. Winner. And then this one, the passenger is that many meters above the ground, 7.5 minutes after the ride begins. The 15.07 is definitely a change in height over time. So it's a meters per minute situation in terms of units. So D is going to be our winner. Sorry, these first two, I missed the word turning. This thing has nothing to do with turning because we're not talking about the wheel itself. We're talking about the height of the passenger. Question 3, dealing with some Riemann sums. If a trapezoidal sum over approximates from 0 to 4 and a right-hand Riemann under approximates, which of the following could be the graph? Well, remember, if a trapezoidal sum over approximates, that means that our graph must have been concave up. And if a right Riemann sum under approximates, that means that our original function must have been decreasing. So we're looking for which of these functions is decreasing and concave up. This is linear, so not going to happen. Increasing and concave up, decreasing and concave down, increasing and concave down. A is going to be our winner. And also you can test it, right? Trapezoidal sum would be too big and a right-hand sum would be too small. And you could do that by process of elimination on all of them. but I think it helps sometimes to think about what each of those terms mean and then put them together into one graph. The graph of the function f is shown above. Of the following, which has the least value? So let's think about this. This graph is concave down and decreasing. Well, if a function is concave down, then the trapezoid rule is an under approximation, and the midpoint rule is an over approximation. If a function is decreasing, then a right hand is under, and a left hand is over. Okay, so if we think about this, we're trying to figure out which one is the smallest, the least value. Well, obviously anything that over approximates can't be the least, right? So then let's talk about this right hand under, trapezoid under. We're supposed to use 4 subintervals of equal length. This is a perfect amount. It's not an approximation, so that can't be it. Here we have a left, that can't be it. Here we have a midpoint, that can't be it. So we're down between trapezoid and right Riemann. We're supposed to have 4 subintervals. So even without finding all 4 subintervals perfectly, although you could if you wanted to, let's just talk about 3 for a second. If I were to do this, okay, that's my right hand rule, versus doing this, okay, which one of those, the blue or the purple, is bigger? Hopefully you're saying the blue, because look at how much more triangle you're getting than the purple, which means the purple is way under what the blue would be. So the right-hand Riemann sum is the under approximation. I should probably circle that in the color that I chose. Under, or the most under, rather. So in this case, another way you could do it, they talk about 4 subintervals of equal length, but just try it with 1, right? If I were to draw in 1 right-hand rectangle, this is my approximation of that area. Whereas if I were to draw in 1 trapezoid, this is my approximation. So clearly the purple is the least value, okay? The least, or I guess the most under, if you will. Talking about least. That was terrible wording right there. I apologize. All right, question 5. The function f is given by the natural log. The graph of f is shown above. Which of the following limits is equal to the area of the shaded region? So thinking about the area of the shaded region, we have a, which is 1, and we have b, which is 4. And we are summing up an infinite number of rectangles from 1 until 4. So the first thing I would do is I would look for my b minus a over n. B is 4, A is 1, so that's going to be 3 over n. So anything that doesn't have a 3 over n on it is out for now, right? This has something with 1, I don't really even know what that was trying to represent, and this one has 4 over n. We don't want 4, we only want 3 over n. So I'm down to these 2. The next thing then I got to think about is it's supposed to be f of a plus b minus a over n I. So f of, well, a was 1 plus 3 over n I. All right, well, I, in this case, they're using k for their index. So this one has a 1 plus, but this one has f of just 3 over n I. I just put air quotes up like you can actually see them. You can't. Where this one is f of, and you've got that whole thing in there, right? Because if our function is natural log of x, then I want the natural log of 1 plus 3 over n I. Or again, in this case, they're using k. So B is my answer. Remember again, that's because you're starting at 1 and you're stepping out to end 3 away, right? So 1 to 4 is a step away of 3. Last one. The differentiable function is increasing and concave down. So if we think about increasing and concave down, looks something like this. Values of r of t are given. The trapezoidal sum is there. Which of the following statements is true? So trapezoidal sum under or over? Well, first of all, if we just think about our trapezoid cutting across, trapezoid is definitely under. So we can get rid of that one and we can get rid of that one. But the reason that a trapezoid is ever under is because of the concavity, right? Trapezoid and midpoint deal with concavity. Right hand and left hand deal with increasing and decreasing. So it's due to the concave down part that makes that an underestimate. All right, probably not my best recap multiple choice video, but you know, still getting the hang of it, still doing it. Ask to have a Google Meet if you would like to with your teachers to go over anything. Hopefully that helped.